On today's episode, I'm sharing for the second time an amazing conversation with Dr. Timothy Nelson, a heart surgeon who is leading a team that is literally building hearts, real hearts, beating hearts, hearts made from the stem cells of children with congenital heart disease.
In our case, we're focused on the rare neglected congenital heart disease. We're building a process to apply regenerative medicine to that neglected patient population. And we've done it on a budget that's a half to a third of what our corporate competitors have done. And we have the world's first clinical trial approved with the FDA with IPS-based technology that nobody else has in the cardiac space.
This is one of my favorite episodes because it is packed full of what Dr. Tim calls creepy cool science. But more than that, this episode is packed full with life-changing, humanity-changing hope. This episode is sponsored by The Dream Exit. The Dream Exit is a private, bespoke program for successful entrepreneurs with annual revenue between $5 million and $100 million who realize that they have one chance to get their dream exit right, and that the odds of realizing that dream by themselves, all alone, or at the last minute are stacked against them. In less than 90 days, we teach you how to design, build, and execute a customized dream exit playbook that gets your business ready for sale at its maximum value and gets you ready to maximize your meaning and purpose in your post-exit life, even if today you are not ready to sell. You see, dream exits just don't happen. They are the result of early, professional, and proven planning. So if you're an entrepreneur with annual sales between 5 and 100 million, and you want to learn how to 10x to 100x your chances of achieving the dream exit you deserve, go to dreamexitplaybook.com today. Get ready to take a peek at the future with Dr. Tim Nelson. Hey, Tim, welcome to the podcast. It's great to have you here.
Great to be here. Thanks, Mike.
So I gave you a little taste of Dr. Timothy Nelson in the intro, and now I'm going to give you a little bit more of his bio so you know who we're dealing with and what you can expect. So Dr. Timothy Nelson is the founder of HeartWorks, an organization that developed from the Todd and Karen Wanek family program for Hypoplastic Left Heart Syndrome. That's a big word, and we're going to use probably a lot of big words today, but I will ask him to break them down so that we can all understand it. But that program was founded at the Mayo Clinic in 2010. Tim's work specializes in the creation of stem cells to create heart muscle and hopefully cure pediatric congenital heart defects in the near future. Do I have that mostly right, Tim?
Sounds great.
Okay, super. So Dr. Nelson earned his MD and his Doctor of Philosophy from the Medical College of Wisconsin, right in my backyard. And he's been a physician at the Mayo Clinic in Rochester, Minnesota since 2005. Tim, I start every podcast with the same question, and that is, how did it happen for you?
It's a great question. Love it. How did it happen for me? You know, it started for me in your backyard there in Medical College of Wisconsin. And my career has been defined by my interest in what's not in the textbooks and how we need to build teams to develop and learn and develop products in medicine that don't currently exist. And so I would say the inspiration of my medical training at Medical College of Wisconsin and the culture there, amplified by the culture of Mayo Clinic, where when I trained in Mayo Clinic as internal medicine and cardiology fellowship, if it can be done anywhere, it can be done at Mayo Clinic. And then it was really the third leg of that stool was my unique opportunity to meet Todd and Karen Wanek and their entire family. They're from Wisconsin, owners of Ashley Furniture, and have made a transformative investment through Mayo Clinic to jumpstart and spearhead what we'll talk about today. And so how it happened for me was my medical training linked to Mayo Clinic, and then the good fortune that at a very early stage, I got to meet Todd and Karen, and we've been in partnership to do what's never been done before, which is truly cure congenital heart disease and build a team, build a platform, It's about people, it's about processes, it's about technology, and it's about weaving all of that together to do the unthinkable. And we haven't done it yet, but we have a good track record, and we're excited about what we're going to be able to do in the future because of what we've done in the past.
And this interest that you have in what's, interested in what's not in the textbooks, Tim, where did that start, and how did it sort of gain traction for you in your life?
Yeah, that's a great question. So my stepfather, who is now passed, is who I grew up with in Western Wisconsin, small town called Osseo, Wisconsin. He and his partner started a rural community practice. He was a general practitioner, and I grew up with him, watching his practice of ER, general practice, family medicine, general surgery. He was a general practitioner. He did it all. And, there's one story I remember from my stepfather as I grew up, that he had this patient in renal failure, kidney failure, came into the hospital in a rural setting and would not survive if you did nothing. It was severe acute renal failure. And he had read a journal article at the time about something called intraperitoneal dialysis. Basically what it is, you stick an IV into the belly and you fill the cavity of your belly with fluid, and you wait a couple hours and then you suck it out, and you keep doing these fluid exchanges inside the lining of the belly wall, and you can dialyze people by what's called intraperitoneal dialysis. And he'd never done it. He had only read about it in a journal, and it wasn't evidence-based medicine, but he had an idea that could potentially save this person's life. And he sat at their bedside doing this all night long into the next day, and told the story of how he saved the life of this person by doing what he thought would be the right thing to do. And I look at those stories as a child and think about that. And the world I live in today in medicine is everything has to be evidence-based, everything has to be proven, everything has to be tested to the nth degree. And it takes away a little bit of that innovative spirit, if you will,
right,
that our rural practitioners were forced to do 40 years ago. And so that really has always bothered me, I guess, at some level, that we've moved away from that innovation spirit, which is justified in many cases. But how can we do it both? How can we have that innovation? How can we innovate, move things forward, test things, and collect the evidence to make it a standard of care as we go forward? If we just live with what's in the textbooks today, we're not going to innovate. And that maybe is one story that helps explain where my mindset was formed as a young person thinking about what I wanted to do with my career.
So I have great memories of Osseo, Wisconsin, because my daughter went to school at McAllister, which is in St. Paul, Minnesota. So the trip up 94 goes straight through Osseo, and it closed, unfortunately, a diner there, like old school diner right off the freeway. I'm sure you remember it.
It's called the Big Steer, I bet.
I don't remember the name of it, but I always it was that point of the trip where you're like, I'm hungry, I would like to get something. And it was just a very cool place. And Osseo itself it's still very rural, right? So
sure.
This story about your stepfather sort of having to innovate on the fly for things like this, maybe Eau Claire is the nearest hospital, I don't know, but you don't have access to close medical care, or I guess intensive medical care, right?
No, it's true. Most of patients in this country don't have access to tertiary referral centers. I mean, most of healthcare is delivered in the rural setting, and rural healthcare is a major challenge right now as we close hospitals and as we consolidate and move services around to improve the services. We also are losing that trust and connection with our local communities, and there's consequences to that. And how do we innovate, and how do we address that is a really, really important topic that those of us that grew up in the rural America can appreciate at a different level than those that didn't grow up in that environment.
Right. Your story of your stepfather also reminds me. I'm watching the show called Lost now. It's an old show, but I never watched it. Have you ever watched it?
I have not.
Okay. Well, it's basically a plane crash onto an island, and there's all these survivors, but there's one doctor. There's one doctor on the island, and everyone naturally goes to the doctor for everything. The doctor's supposed to know everything. And when you're talking about, not working out of the textbook, there's no textbook, there's no facilities, so everything is, it just reminds me of, that's a really, really rural example of what your stepfather was doing in the story.
Yeah, no doubt. And, these pioneers, if you will, are what has created the modern medical practice that we have today. And, I often have wondered in my career, is my generation going to be as innovative as the generation in the 60s? And it's amazing to think about what was done in the late 50s and throughout the 60s in medical advancements and in surgical practice and clinical care. And it's really, really remarkable to go back in time and think about what resources and knowledge they had and what they were able to muster and pioneer. And we're doing some amazing things today, for sure. And are we doing it in the same innovative spirit, with the same sense of urgency, with the same sense of, if we don't do this, who will? And if we don't do this now, what ground are we losing? And I think that sense of urgency and pride in the 60s in medicine is a time period that is really inspiring to me. And I believe we can do more and better. But we have to be very cognizant of how we promote biomedical innovation and how we protect it, support it, and grow it, because it doesn't happen by itself.
So let's explore that a little bit more, Tim. What has you thinking or questioning that the current generation may not be as innovative, because all you read about are potential innovations now, where back in the 60s, I was a young kid, but I'm pretty sure that you weren't, reading about breakthrough biomedical innovations on a regular basis like you are now.
Yeah, it's a great point. So thanks. This is my perspective, right? And this is why we talk about these things and debate these things. I think the technology today is uncomprehendable. The technology of regenerative medicine, of genetic engineering, of CAR T technology. I mean, we can go down the list of the miracles of medicine and from a technology standpoint. The problem, the challenge, is getting it out of the lab and into the clinic. And the regulatory environment and the academic structures that technology is developed in has what's called the valley of death, that things get published. We talk about it, that, someday we'll be able to do X, Y, and Z, right? I mean, I'll tell you what, that someday we'll be able to do X, Y, and Z in medicine is the thing that drives me and annoys me at the same time. Because who's the team that is going to make someday possible today, right? Who's going to actually do that? And so a lot of the technology, I think, lives in the lab, and we don't have structures to get them out of the lab into clinical trials and get them to the patients that need it. And that timeline of time to patient for technology to patients is grossly too long. And we can take on a controversial topic here if you want, and think about the COVID vaccine. And there's two sides to this story, for sure, like every story there is. But from my standpoint, the science that went into that development and the scale and the speed that it did it at was exactly the type of thing we need to do more of. That science is primed to be able to do biomedical innovation at a time scale that we can improve. And I think that the pandemic on so many fronts, from technology, from medicine to the technology sectors, forced us to innovate on a time scale that we've never been asked to innovate on before. And we did it. We did it well. There was hiccups, there was challenges, no doubt. But this is what we can't snap back now in the post-pandemic era. We have to be inspired by the fact that the challenges from the last couple of decades in medicine and health are our inability to have a sense of urgency to get the best technology out of the labs and into clinical trials. And that's where we have to work to develop structures and systems to do better on. And I think that's really exciting. But that's where I see the difference that, yeah, the news reports of technology are really inspiring and interesting, but I know all too well the gap between that initial report and what it's actually going to take in our regulatory environment to get that into a standard of care model at some point in the future. And that 20-year time gap is just unacceptable.
So let me dig into that a little bit. At the end of that story, you mentioned the word regulatory. And as you were talking, the word permission came into my mind. So as I understand it, the rapidness with which the COVID vaccine was not just developed, but also approved was largely due to this emergency use. I don't know if that's the right technical term, emergency use thing that the FDA can do to basically, but they do that. They use it very rarely, is my understanding. And are you suggesting that emergency use or some other pathway that would help limit the time from, development to approval, or at least to trial, would be helpful? Or I guess I'd like to know where you are on that. I know it was certainly helpful with mRNA vaccines, right?
Yeah. So there's definitely lots of pieces of this puzzle, right? And there's no one simple solution, but it's 100% true that in the United States, the FDA is a critical component to getting technology out of the lab and into patients. And for very, very good reasons, because it protects the safety of our public and it protects the public from, rogue scientists and rogue technology that could do more harm than good. And having that counterbalance structure is critical to having a vital system that can move rapidly. We all have to trust the system, and we all have to leverage and work within that system to be our best. So the FDA has been nothing but constructive in my world, and has helped us accelerate what we do. And the FDA, in the agencies of regenerative medicine, stem cell biology, and all the INDs that we hold with the agency, they've been incredibly productive. And because we built a team, in my opinion, that can develop the data and the time scale that the agency needs to do a proper review. And you can do this in the right way. Obviously, emergency use authorization can streamline things, and you don't want to do that on everything, because then you're creating a pathway that isn't as rigorous perhaps as what we need for other conditions. So, I'm not suggesting that we should do that all the time, but what I am suggesting is it shines a light on the fact that we can do it better. And all systems working as an ecosystem can and should be expected to do better going forward. And academics in the basic science research and the product developers need to take the responsibility to be part of a more effective system. And at HeartWorks, and what we're doing with stem cell therapy and regenerative medicine for congenital heart disease is, I think, taking a pioneering approach to allow us to do it better and do it on a time scale that's more cost effective. And so I'm inspired by the fact that we can do more, and I'm inspired by the fact that there's examples out there that are doing it better. And if we don't take this on seriously as a group, as an ecosystem, healthcare costs are going to continue to go up to the point nobody can afford it, and our outcomes are not going to get any better. That's the reality. If we're not innovating, right, we're not going to be making it better. And so my belief is that we need to activate the entrepreneurial community. I think that this is the catalyst that we are, in the last 5 to 10 years, have gotten much better at activating the entrepreneurial community. But I think we're on the tip of the iceberg. And when we fully activate the entrepreneurial mindset and the entrepreneurial community and align it with productive product development in the biomedical space, we can do the regulatory work, and we can accelerate the pace of which effective products get to patients that are currently being neglected. And that's my belief, and that's what we spend our days trying to improve.
So I think as you were talking there before you got to the entrepreneurial part, you were alluding to some of the partnerships and collaborations that you've been able to put together with other children's hospitals across the country to basically extend the reach of the research and that's going into your stem cell research. Is that correct?
Yeah. So let's focus on the big problem here. The big problem that we're touching the corners of are the timeline it takes to develop products in the biomedical space. And the time equals dollars. And when that timeline and dollars are bigger and longer than what anybody has in their venture capital money market, the thing breaks, right? So if you're dealing with a common disease, high blood pressure, diabetes, Alzheimer's, neurodegenerative, there is a lot of money available in the angel investment, venture capital, early stage investments, because there's a blockbuster breakthrough opportunity for those investments because the market size is big.
Big market, right?
So we have a system that is calibrated around that and works relatively well, honestly. But when we talk about rare and neglected diseases that aren't big market sizes, there's no incentive to innovate technology for those diseases. And ironically, Mike, what's really fascinating is those rare diseases that have no treatment options, that have very poor outcomes, are the exact patient populations that are ideally suited for disruptive technology, right? And so how do you focus disruptive technology in that rare disease when the money's not there and the FDA requires robust data to get it into a standard of care? How do you bridge that valley of death? That's really the secret of HeartWorks, is leveraging the philanthropy, leveraging the partnerships of academic institutions, and building an ecosystem that's committed to the long term, that can extend the runway to do product development sufficiently that the FDA will allow us to get products approved. And when we get to the tipping point that disruptive technology is prime time, is de-risked, we have a structure that we can bring the capital markets into it, because the timeline for a profit-making activity is short enough that we could engage the VC world to take the next leg of the run. So, it's building an ecosystem, and our academic partners have been instrumental in being able to build that foundational platform to be able to do this in a time scale, in a cost-effective way that isn't done in any other structure that I'm aware of.
Hey, everybody, just a quick pause here to let you know how much I appreciate that you've made time for my podcast. If you're not already a subscriber, please become one today. Leave a review and tell a friend. Now, let's get back to the show. And is the value proposition in that approach, particularly when it comes to the rare or incurable diseases, current rare or incurable diseases, is the value proposition is like, hey, if we can figure out a way to cure this disease, it's exceptionally likely that part of what we learn will be applicable to curing or improving outcomes in a lot of other diseases. Tim, is that the value prop?
100%. So think about how medical innovation happens today. We take the big blockbuster diseases and we put the disruptive technology in big $100 million, multi-hundreds of millions of dollar increments to develop technology. And then if it's proven there, we can drift it down into the rare and neglected diseases. That's generally the way things flow because of where the money is at. But let's flip that model around. And let's take the most innovative technology, the most disruptive technology, focus it on the most severe, rare, neglected disease populations, and get the clinical data that is the critical data that is at the tipping point, the inflection point of product development, is clinical data in the hospital with real patients, that we can show the safety and the efficacy in this patient population, balancing the high risk nature of the technology with the no option patients. When we build a system that can win that race with a sense of urgency, We now have the clinical data that immediately can be scaled to more common diseases. In our case, we're focused on the rare, neglected congenital heart disease. We're building a process to apply regenerative medicine to that neglected patient population. And we've done it on a budget that's a half to a third of what our corporate competitors have done. And we have the world's first clinical trial approved with the FDA with IPS-based technology that nobody else has in the cardiac space. So with this approach today, our track record of success is we've done it faster and cheaper than the traditional model. And when we have the clinical data now that will come to us in the next couple of years, we'll be in a position to make an informed decision of where to scale that into the adult ischemic heart disease patients, the acquired heart disease that we typically think about with heart failure. That's the big market. But we will have the clinical data in the rare market to be able to be well positioned to scale the technology and bring it to broader markets. That model, I believe, is the secret to accelerating and expanding the disruptive technology that's available to our healthcare system.
And you used IPS, that is induced pluripotent stem cells, for people who don't know what that is. And we're going to dive into that a little bit later. So you'll have a really good sense, because that's a key part. That's the key, right? That's the key to the work you're doing right now.
Correct.
When you were describing that, it made me think again back to the mRNA vaccine, because as my limited non-medical understanding of it goes, that technology had been, first created, I guess, maybe for avian flu, and then avian flu sort of went away. And so the funding for it kind of, no one was interested in it anymore. So it was kind of going on in the background, because there was, just like you said, there's this potential, at least for mRNA and, this protein-based vaccine to cure the common cold, maybe even, there were all of these things kind of going on. But then when COVID hit, it was basically activated. And that's why it was, I guess it was easy to sequence, at least initially, easy to sequence the COVID strain with, and they developed a vaccine. But it was not something that, it wasn't like huge on the radar of going anywhere, because it was thought that it was sort of this narrow thing for avian flu, or maybe some of the other types of bird flus. Is that halfway right?
Yeah, I'm not an expert in this field, but from my outsider perspective, which is similar to yours, I think you described it right. And the way I choose to see this is that the convergence of technology with mRNA vaccines was there. The academic research was done. There was lots of data, but we needed to have a sense of urgency to make it applicable and put it to use. And there was just no other way to do it on the time scale that we believed needed to be done at that time. That became a tool in the toolkit that could address the time scale that we faced. The essence here isn't the technology, isn't the FDA regulate. None of that is what I focus on. What I focus on is we had a sense of urgency. We had a sense of urgency in this space of healthcare, and it allowed us to make the best decisions we could make with the information we had and move things forward for the benefit of our society, of mankind, if you will, because we had a collective sense of urgency.
Yeah.
And I'll submit to you that sense of urgency is something that we need to rekindle across healthcare. And what I mean by that is there are kids with congenital heart disease that I have known in my life that are no longer with us. 50% of these kids with complex congenital heart disease won't make it to their 5th birthday. This should be unacceptable to all of us. And this should be the sense of urgency that we need to develop better tools to make our surgical techniques more efficient. And when you take that sense of urgency, you will make decisions that are never going to be perfect. They're always going to be debatable. Innovation is always going to be a debatable topic, but the sense of urgency is what gives you the rudder to sail through those turbulent waters, if you will, and make the best decision you can and learn and grow and build. And I think that the sense of urgency in the rare neglected patient disease population is the biggest asset that has allowed us to get to where we're at. We've got a great team. We've got great investors. We've got great everything. Everybody does. But what we have that's unique is time to patient is a driving force with a sense of urgency. If we don't do this year, there is going to be calculable number of patients that die again. And if you extrapolate that over a 10-year period of time, it becomes very motivating to everybody involved to make the best decision possible to move technology forward as rapidly as possible. And I think anything that can rekindle or amplify or tell the story of the urgency that we have in healthcare is so vitally important to align decision makers.
So as I understand it, 1 in 100 children are born with some type of congenital heart defect.
Correct.
Right? 25% of those, give or take, require some sort of surgery. And I've heard you talk before about surgery being really addressing the symptom and not a cure. And I wanted to go back to your mission. And this mission that you're on to help these children, when I guess, how close was it to not having ever been on your radar, Tim? And what I mean is, we mentioned Karen and Todd Wanek in the intro, and how, you happened to meet them at some point, and their daughter had an issue, anyway, that's sort of the convergence of how it all came together. But I'm wondering to myself, how did that come together? And was that your mission? Was that on your radar before this relationship happened, before this this interaction or relationship happened?
Well, so it's interesting to think about this. So I remember, I'm thinking of the story because it's in your backyard at the Medical College of Wisconsin, as trained to be a cardiothoracic surgeon there. And I got a very close relationship with many of the surgeons there. I spent a lot of time in the OR, mostly with Dr. Jaquist, who was at Medical College of Wisconsin, now is in Dallas. And I spent many, many hours with him and his team at Children's Hospital of Wisconsin in the OR, because I was planning to be a cardiothoracic surgeon. Mm-hmm. And I developed this relationship with all of the colleagues there, so that at the end of my time, I made a proposal. I made a research proposal. And this shows you, this is kind of a funny, naive story that I can share with you. It will show how naive I was at one point. I was using mouse embryonic stem cells at the time and creating mouse hearts in the lab. And we were dealing with these patients that did not have strong heart muscles. But I make heart muscles every day in the lab. It just happens to be genetically mouse cells. And there's the concept of xenotransplant, where we put animal products into patients. This is nothing new. So I remember making the proposal to our surgical colleagues at the Medical College of Wisconsin and Children's Hospital. Why don't we use mouse cells and create mouse tissue, which is contracting, beating heart muscle, and use that to surgically augment the patient's heart that doesn't have sufficient heart mass to do the workload it needs to do. So mouse cells, mouse heart muscle into patients. Stupid, crazy idea, right? I mean, like as you might imagine, I got laughed out of the room, literally, right? And people said, "Oh, now our patients are going to start growing tails and growing hair and ears and." And I get it. I do get it. I get that the medical experts in the room were very kind, respectful people, but it's a crazy idea that only a medical student could propose, right? And yet it highlights some interesting things. It highlights that, one, we have a medical expert mentality that very quickly dismisses innovative ideas, no matter how crazy they are, because it's just not clinically relevant today. I'm not going to do that today. There's decades and decades and decades of work that have to be proven before we could entertain an idea like that. I get that. But then who is going to do it?
Experience is the enemy in
correct
sort of thing.
Exactly.
Right? Yeah.
The expert, the tyranny of the expert at some level here, right? But that was the idea when I was a medical student, and so I don't know that that idea was a fleeting idea. I think that that idea kind of got baked into my head, as it did with many people in that era. It was in the Bush era of embryonic stem cell debate, and the induced pluripotent stem cell technology with Shinya Yamanaka was discovered then, and we had pluripotent cells that were human origin, that could do everything that an embryonic stem cell could do. And suddenly, this crazy, stupid idea of using mouse cells was like, no, we shouldn't use mouse cells. We should use human cells. And so, the idea was there. There's no doubt about that. But I'll tell you what, Todd and Karen Wanek are two of the most remarkable people I have ever met, because they were willing to make an investment in an idea, not in a team, not in a track record, but in an idea at a stage that it was a crazy idea. And it was me saying something like, well, shoot, we've done this in mice. Why can't we do it in humans? And they said, okay. And it was that simple idea and the belief that we should be able to do it, that only them would be able to invest. I hope they inspire others that are capable to be willing to make those bold predictions and investments. But I also hope that those bold investments are held accountable to building a team that can ultimately succeed. And that's ultimately been the success of our partnership, is building a track record of success and a team that can take these crazy ideas and do the impossible. And so I don't think I'd be where I'm at today without Todd and Karen. There's no doubt about it. I'd be still propagating academic ideas and getting laughed out of the room. But because Todd and Karen breathed life into that, here we sit with the world's first FDA approval to do the world's first clinical trial. And that's directly because Todd and Karen were willing to take a bet and see if we could play this out.
Okay. And that's often how it goes. Somebody has to take a bet, right? Somebody has to make a bet. And oftentimes, if I understand their story correctly, they had a personal attachment to a problem in their family. And that's like, reminds me of, have you ever heard of Martine Rothblatt?
For sure.
Yeah. So it reminds me of her story as well. It's sort of the same
100%.
thing. Got something that no one's curing. We got to figure out how to do this.
And you know what that comes back to, Mike? It comes back to when I hear those stories, it justifies my opinion that it's the sense of urgency that is the key element that makes this all work. It's not the money, it's not the technology, it's not the people. All of that's a commodity that's available at some level. The thing that crystallizes this to have a successful outcome, like what Martine has done, like what Todd and Karen have done, is a sense of urgency. And frequently that sense of urgency is the inspiration of the individual family members that we know. And those people are hanging on my wall right next to me right now, because those are the people that give our entire team the sense of urgency and the commitment and the conviction to make the tough decisions, to not let this just wither in the lab, but to get it into real life applications.
So you mentioned a couple of things that I'd like you to explain a little bit further. So first of all, this whole notion of stem cells, it's something that I think everyone's probably heard of right now, but they probably can't define what a stem cell is. So I'd like to just start basic there. And you did mention embryonic stem cells, which would come from fetuses, right? And that was a big ethical dilemma, and still is. But I think what's become so interesting is that you no longer, and your work proves it, and a lot of others, that you're no longer you're no longer only there. That's no longer your only source of stem cells. You can basically create your own stem cells from your own body, which is the work that you're doing now. And then you mentioned Yamanaka, and if you could just explain those couple of things, Tim, that would be awesome.
Yeah, you'll have to dive in and cut me off, because I could talk for hours on this, and I don't think you or your audience would want to have the full medical school lecture on this. But the short shot of this is stem cells is a terrible term. Stem cells is like using the word automobile. And what do I mean by that? When you say I drive an automobile to work, it means nothing, right? Other than it was probably four wheels and a steering wheel. And maybe that's
Hmm.
even going to change at some point. But, there's a dramatic difference between the pickup truck, the Mercedes SUV, or the Hyundai two-seater, right? I mean, automobile means nothing to anyone. You have to be more specific. Stem cells is equivalent to automobile. There's lots of different types of stem cells, lots of different sources. And just using the word stem cell is completely useless and very disruptive. So you have to get more granular with what you mean by the word stem cell.
Okay.
And so stem cell, by definition, is a cell that can asystematically divide, which means it can create a daughter cell and preserve its own identity. That's the medical word for it. A daughter cell is a progeny that can go off and become anything else, and you can recreate yourself. That's in essence a characteristic of a stem cell. The other essence of it is it can grow indefinitely. So grow indefinitely, we typically think of cancer cells grow indefinitely, but a stem cell can also grow indefinitely. So these are the characteristics of what makes up a stem cell. So said that in layman's term, a stem cell is a seed that can grow new parts, new plants, and it can grow certain plants. And that plant can create a seed that you can harvest and replant it and regrow. So a stem cell is, in many ways, you can think of it as a seed that grows a plant that can grow another seed, and you can continue to grow and populate a field and build an agricultural industry around it. But just like in agriculture, different seeds mean different things. There's soybeans, there's corn, there's wheat, there's even good and bad corn seeds, right? That give better yields in
Hmm.
different environments that require different germination, different watering cycles. So stem cells are seeds. You can get those seeds from different places and they can grow different things. The big ones are embryonic stem cells. Embryonic stem cells are what gave rise to your entire body. They were a collection of a few hundred cells when you were a few weeks old in your mom's body. Embryonic stem cells give rise to every single cell in your body, head to toe, period. Now, to isolate embryonic stem cells in the lab and to do the work, you generally have to destroy an embryo to do that. And that creates the ethical dilemmas of human embryonic stem cell research. And those ethical dilemmas will never be solved by science or data. They're ethical dilemmas that are not solvable by science.
Mm.
And it wasn't until Shinya Yamanaka discovered that you could reprogram ordinary cells, such as a piece of your skin, to look and feel and behave like an embryonic stem cell, send it back in time so that it had the same capabilities as an embryonic stem cell, but you didn't make or destroy an embryo, and you made that cell from the patient's own body. This was the Nobel winning prize breakthrough that Shinya Yamanaka had that's called induced pluripotent stem cells. This is
And,
the game changing technology.
and how is that different than CRISPR?
Yeah, so CRISPR is really a genetic tool, right? So CRISPR is an approach that allows you to go in and manipulate the DNA, and you can cut things in, cut things out, insert things. So it's a gene editing technique is how you should think of CRISPR. What
Okay.
Shinya Yamanaka did was introduce genes, the four Yamanaka factors, and you can introduce them in multiple ways. They would transiently express in the cell, meaning express for maybe 3 weeks, 4 weeks, and then disappear. So you only had to express them for a limited window of time. But when you express those genes exogenously that weren't there until you introduced them into the skin cell, those genes will reprogram the cell and will kickstart a memory process to send the cell back in time. So at the end of the reprogramming process with Shinya Yamanaka's technology, there's no genetic modification of the cell. There's no alteration of the original DNA. It's a transient hit and run mechanism that really just triggers the cell to remember what it was like to be an embryonic stem cell, but you're not permanently genetically engineering it like CRISPR technology would do.
Okay. So it's like a psychological thing, basically reprogram the cell, the psyche of the cell to
I think of it in terms of a memory as a productive way of doing it, right? What's the earliest childhood memory you have, right? And we're creating an environment in the cell to cause that mature skin cell to remember what it was like to be an embryonic stem cell at its very earliest form. And then once you cause it to remember that, it starts behaving that way as well. And the biology is creepy, right? I mean, the telomeres are the ends of the DNA that are the length of the telomere is your chronological age. And the older you get, the shorter the telomeres become. When you trigger this memory to become an iPS cell, the telomeres actually elongate. The whole chemistry of the cell, the epigenetics, get reprogrammed so the cell literally looks and behaves like it was as an embryonic stem cell. You're literally sending the cell chronologically back in time, but it's really the memory of that triggers it. It's not a permanent genetic alteration that does it.
And then it stays that way. It stays young.
It stays that way. We can propagate the cells at induced pluripotent stem cell indefinitely. There's principles. The Hayek principle that says 54 populations doubling is what can be done. That's really been taught to us from the oncology world and cancer cells. We've never had an induced pluripotent stem cell until a decade ago to really know how long these can go. But essentially, indefinitely, we can freeze and grow these cells, and then we can train them to become any cell type in your body. In our case, we like to train them to become heart muscle. But you theoretically could train them to become any cell in your body. And that's the definition of a stem cell. It can grow indefinitely, and it can symmetrically divide to create progeny, heart muscle cells that are unique and different from its parental pluripotent starting material.
Okay. And so in a simple way as you're able, can you describe the work that you're doing right now from the time you take the skin cell till you're ready to implant it, I guess.
Yeah. So what we have FDA permission to do, and we are currently launching the clinical trial with now permission at Mayo Clinic in Rochester, Minnesota, is HeartWorks will start with a skin biopsy from a patient with congenital heart disease that has end-stage heart failure. So a patient that has no good options for current medical management, not even a good candidate for a heart transplant. These very sick patients that have no options we will take a skin biopsy. We will grow the cells out from the skin in the lab. They're called fibroblasts. They grow on plastic plates in the lab, and then we reprogram them with the Yamanaka factors that do what we just talked about, which triggers the cell to remember what it was like to be an embryonic cell. Those cells look different. They behave different. We grow them. We cultivate them. We test them to make sure they are what we think they are. And then when we get them at a large enough scale of these induced pluripotent stem cells that are genetically identical to the patient we biopsied, we then train them to become heart muscle cells, which are beating, contracting heart muscle in a bioreactor apparatus in the lab. We do it, essentially it will fill the palm of your hand with like 5 mils of a cell pellet of beating, contracting heart muscle cells. And then those cells get surgically transplanted into the patient's heart to remuscularize and rebuild the patient's heart. This has never been done before. This is the first time that the FDA has ever approved a protocol like that. So we are doing it to ensure that we can do it safely, that we can show that we can feasibly do this. And the reason we believe this is important is because in our laboratory studies, we can show that these cells will engraft in heart muscle and that have the potential to rebuild the heart. that's the hope that we will get this technology to. But it's important to realize that the stage of the process we're at right now is literally treating the first patient, the first 9 patients in this protocol, to make sure that we can do it safely and feasibly accomplish it. It's a 9-month manufacturing process from the skin biopsy to having the product ready to go. So you can imagine the logistical challenges along the way. Every single day, somebody is taking care of these cells in the lab 7 days a week to be able to make this process happen. So there's definitely things that can go wrong and fall apart. And so that's what we're working to perfect and make this a feasible strategy to test on larger number of patients.
And right now you're working, these 9 patients could be any age, as you mentioned, that basically beyond the point where there's a current cure or solution for their problem.
Correct. And there'll be more information that will be coming out of our clinical site at Mayo Clinic in Rochester, where we'll be able to communicate what exactly the inclusion criteria is, and the clinicians will need to be involved to very carefully select those. But essentially, it's going to be adults. It's going to be patients that are 18 years and older, and it's going to be patients with congenital heart disease that have end-stage heart failure. That's the essence of it, but there's a lot more details that go into making sure that we're picking the right patients for this study.
Okay. And you may not know the answer to this yet, but I'm curious as to the thought, like you graft this on, or however it gets put on the heart. How long are you thinking it could or should, or hopefully would take in order for enough muscle to be built that the heart starts to function normally?
So start with the ultimate long-term vision of what the technology means. Because it's autologous, because it's genetically identical, once it engrafts, we expect that it will be permanently engrafted, which is a remarkable thing to say. We don't have the data to prove that because it's never been done in a patient yet. But because it's genetically identical, the science would lend itself for us to believe that it could be a permanent long-term engraftment. Now, the cells we inject, do they grow? Yes, they probably do at some level. And then they mature over the course of 2, 4, 6 weeks. And so there's probably a period of time measured in months where the engrafted product would mature and grow to the point where we'd expect it to be quote unquote beneficial. But what's really remarkable about what this technology offers is you don't need immunosuppression medication to keep this engraftment in your body, because it's genetically identical to your body.
Yeah.
So it, in theory, should be permanent engraftment. Those are questions that we obviously will only get with careful clinical trials with appropriate follow-up.
Just a short break here to ask you a question. Have you read my book? It's called Ownership: How Getting Selfish Got Me Unstuck, and it's available on Amazon, Audible, and everywhere else. If you're looking for inspiration that will help you unlock your greatness and potential, order or download your very own copy today. Going back to your mouse example earlier, your crazy idea before, and whether it's mice or pig hearts or whatever is currently being, or I know pig hearts have been used. One of the biggest problems is rejection. Your body doesn't like the fact that something new is in it. And
correct.
With your own stem cells, you don't have that problem.
And there's evidence to back this. It's not only theoretical. There's evidence to back this, and there's published work that shows that indeed these cells do not trigger an immune response. And so that's really the exciting, game-changing part of this disruptive technology. Now, what's important to realize to build on the model here, Mike, a little bit, is the science is creepy cool. There's no doubt about it. Most commercial partners that are leveraging this technology right now are going to an allogeneic model, which allogeneic means that they're trying to build a one-size-fits-all, right? They're trying to build the universal donor stem cells so that they can treat any patient, anytime, anywhere with one lot of cells.
Like
that's different.
Like O positive blood or something.
Exactly right.
Okay.
It's that universal donor concept for iPS cells, and it's a brilliant concept. It could help drive down the cost, scale it, and there's a reason why we should be excited about that. We're taking an opposite approach. We're saying we're going to build custom house for everybody that wants one. We're going to take the time and the money to build your heart for your body. We're going to try to prevent you from ever needing a heart transplant by rebuilding the heart that you have, whether it's 80% defective or 10% defective. We want to try to rebuild your heart with your tissue. We believe that that's a superior product, but you'd never do that without taking an approach like we are with a rare pediatric indication and testing that in that population. And then with the clinical data that we acquire, be prepared to scale it beyond that. So
Mm.
we are fundamentally taking the long road, the more expensive road, but we believe this is really the disruptive, transformative role that could really fundamentally change transplant medicine if we can drive the cost down and show the reproducibility of this as building one product for one patient. It's the ultimate definition of personalized medicine.
Yeah. Oh, and a doorway to reversing aging and all other kinds of things as well. It seems like to me.
No, right. One thing, Mike, it's really exciting. You make me think about these things that I realize that many people don't realize is that your body is regenerating every day, right? Every single day. If you cut your skin, if you have an injury, if you have a soft tissue, major surgery, your body has a remarkable ability to regenerate more than you appreciate, more than we appreciate in the healthcare world. And so this concept of self-healing and regeneration, we take for granted, right? And it's there. It's what allows us to age healthy. So really the technology that we're talking about right now, the ultimate personalized regenerative approach, is really quite simply just augmenting what our body already does.
Mm.
And if we can build your tissue to heal your body, this is the ultimate solution. And we believe that we can do this on a time scale and a cost-effective strategy for congenital heart disease that can prove a new paradigm here. But keep in mind, we're not inventing new biology here. We're really just leveraging the biology that happens every single day in our bodies.
Right. That's just listening to you, I get the hair on my arms is kind of, getting up because it's like, oh my God, can you imagine? So Tim, I've got like a bunch of different things I want to talk about, but we don't have a bunch of time left. So I think I'm going to go to you as an entrepreneur. So I first came upon Tim listening to a podcast called Free Zone Frontier that Dan Sullivan and Steve Klein do. Dan Sullivan from Strategic Coach, who I've talked about a lot on this show. And Dan was very high on Tim and this work and the work that HeartWorks is doing. He compared your work to like Edison or Einstein's work, which is high praise, I think, from him. But he also, you guys also started talking about you as being really an entrepreneur here, like the Waneks, and not just a physician. And I want to just get your take on where your thinking is about that.
Just to be clear, Tim Nelson does not belong in the same sentence with the other folks that you just mentioned.
Okay, well, maybe not yet, but
and what we're doing is a function of a remarkable team, and I'm very grateful for Dan to try to put his view and light on this, because Dan is helping us translate what we are trying to do into a very practical next steps. And I'm so grateful for Dan. I'm so grateful for this community, and I'm part of Strategic Coach. I'm proud to admit that. And one thing that you or others that are in part of Dan Sullivan's universe are asked to do is to introduce yourself to the group on the first day. And the exercise is to introduce yourself as, I am an entrepreneur with special talents in what? And I've never introduced myself that way. until I was forced to, in peer pressure and in strategic coach, if you will. And when I did it, to Dan's credit, he's a genius. Dan Sullivan is a genius, and what he's created is, I'm an entrepreneur with special talents in fixing broken hearts. And when you put it in that context, it changes the way you think, it changes the way you partner, it changes the way you assign the time and energy you have available. And it really prioritizes you in a different way that, in my opinion, is been very, very catalytic for what's next for HeartWorks. And I'm forever grateful for Dan and Baps and their friendship and their ability to help translate what we are doing into a world that can be empowered to make the change.
It's funny, as you were talking about that, I was thinking to myself, okay, so now, Tim, you're in a room at Strategic Coach with people who you tell that mouse story to, and they go, how do we make that happen? Instead of laughing you out of the room, like that'll never happen, right? It's just a whole
100%.
different, a whole different thing.
100%. You know, I was watching the Apple original commercial, Think Differently.
Oh, yes.
Have you even seen this going around on LinkedIn and whatnot? I'm sure everybody has seen this at one point of Steve Jobs giving his lecture and of how they came up with the original campaign on Think Differently. And then he plays the original commercial, and it talks about the people that have changed the world, that have thought differently, that have, and they go through all of the pictures of these people that you're referencing, that none of us can possibly think of ourselves as being in the same company as them. And at the end, it says Think Different, and the Apple logo comes up, right?
Mm-hmm.
And I'm an Apple fan, so anybody that knows me that I'm enamored with everything Apple does. So that's one of my quirks, I guess. But the commercial is really powerful, right? Because it's exactly what you just said. It's not the experts in the room that say, you're an idiot. It's the people that are willing to think differently and say, why not?
Yes.
Why not try that? And that's why I fundamentally believe that we do need to, as an ecosystem, activate, empower, and bring to the forefront the entrepreneurial community, because they not only have the skills to do it, they have the resources to do it, they have the vision to do it. And our healthcare system needs to be inspired by that vision and that entrepreneurial spirit. We're doing much better today than we did 10 years ago, 20 years ago. But I think we're just on the tip of the iceberg, and doing more of that and leveraging that is going to benefit all of us.
Yeah, and it makes me think. Our earlier conversation, we were talking, and we're not going to be able to get into it today, but you mentioned it once or twice, venture philanthropy, and with $1 trillion in donor advised funds sitting in families' estates. All money that's been earmarked to be donated to a 501c3, but becomes a challenge. There's many challenges. One is, you want to keep earning money on it. The second is, who do you invest in, right? Where do you go with it? But one of the things that my wife and I have participated in, and it's a Wisconsin thing, which is why I want you to be introduced to them. It's called Bright Star Wisconsin, and Bright Star is effectively a venture capital philanthropy where people take money from their donor advised funds or other monies that they want to commit to causes that make sense to them, and they donate as an investment into Bright Star, for example. I'm sure there are other models out there like that. And then Bright Star invests in companies, real companies that make real products or real innovations, like what you're doing at HeartWorks. They bring something to market that changes maybe a discipline, or maybe an experience, or maybe a life, or maybe the world, and they invest in that company and they support it. And then when that company, if it survives and grows and thrives, the money comes back and they reinvest it again. It's not like a one-time donation to a charity that they're going to need that again next year because they're not generating anything on their
Yeah,
own.
it's 100% the right model to be thinking about, and this is
Yeah.
exactly what this self-sustaining model, and extending the runway with philanthropic dollars to be able to get to the capital markets and then allow those events and those wins to feed back to the sustaining activities of the research. My belief is that heart work, or that the limitation in this community is not money. It's not inspiration. The donor advisor fund money is a perfect example of it. The limitation is teams that are operationally moving the needle forward. And go back to Dan Sullivan's book, The Gap and the Gain, which my entire family is reading right now. And we got to focus on the gains that we're making. We got to focus on the teams that are building the pathways to clinical trials, teams that are getting the clinical trials, teams that are doing the work, and the gains that they're made. Those are the teams that are investable teams,
Right.
to be able to have a shot at the sustainability that you're talking about. And Brightstar and other organizations are eager to make investments in organizations that are making effective gains. That's what it's all about. Problem is, we don't have great number of teams that are built to be successful in that arena. We've just not incentivized and built teams to be investable teams. And I think that's where my energy and that's my hope, that the HeartWorks model can inspire other teams to be able to do similar things, because the money and the inspiration and the desire is there. Couple that with a sense of urgency and build a team that's investable, and we literally can change the world.
And just, I know this is relatively new for you, but just you talking about it and talking about it in the spaces where people actually are listening to that part of it, not what I think is so cool is that people like me and people in Strategic Coach, Abundance 360, and some other Brightstar, they may not get everything that you're doing. They may not understand, certainly don't understand at the level that a physician or someone like you understands, but that doesn't matter to them. What matters is the belief in you, the belief in wanting to make a difference, and the belief that taking a chance is what's needed, right? That's like sort of the way that you bring urgency to someone. Take a chance, like you said, the Waneks did. They made a bet.
Right.
Made a bet.
And there's going to be a small number of people that will be able to make the bet that the Waneks made, right? I recognize that. And there's going to be a small group of people that are mentally capable of making a bet like that. But there is a great number of people that want to get on a winning team. And so if we can build those pathways and show the progress that can be made, and you get people realizing that whether they're in wealth management and they've done well themselves, they have a niece that's affected by a rare condition, they dream about being part of a team that can move things forward and make a difference on children like their niece. And then they find out about teams like HeartWorks that are actually doing the work and moving it forward, and realize that HeartWorks as a nonprofit, with a plan of growing towards sustainability, that we need partners, we need advice, we need guidance, we need connections, we need resources. You become a partner in the HeartWorks model, right? It's not a passive investment, it's an active investment. And now people, and I've got many examples I could share with you, where now people are saying, I've never been more excited in my life, because I feel like all of the wealth I've created can now be deployed in a meaningful way, and I can watch and see and observe the progress, and I can use that progress to inspire other people to do the same thing.
Right.
I know that we are on the tip of an iceberg right now, and when we show this model can work, it's catalytic. And I've said this before, but the best part of my job is watching one of these financial partners, if you will, make an investment, make a donation to HeartWorks, test us with a major gift, and then see what we do with it in a year. And we have a conversation of what we did, and their eyes light up. because they have not been part of a biomedical research team previously that had the progress that goes from the lab to the patient. And when people realize that they had a meaningful role in doing that, they weren't just making an investment and watching it on the sidelines. They were in the game themselves. It's catalytic.
Well, that's a great word to end on, catalytic. I like that a lot. Dr. Timothy Nelson, thank you so much for being on the podcast today and sharing the HeartWorks story. And it's really amazing work. And I'm very excited about it. And I think my listeners will be very excited about it too. Thank you for doing it. Thank you for being on the show today.
Thanks, Mike. My pleasure.
Hey, everybody. Thanks for listening to the show. And before you go, I just have 3 requests for you. 1, if you like what I'm doing, please consider subscribing or following the podcast on whatever podcast platform you prefer. If you're really into it, leave me a review, write something nice about me, give me 5 stars or whatever you feel is most appropriate. Number 2, I've got a book. It's called Owner Shift: How Getting Selfish Got Me Unstuck. It's an Amazon bestseller. And I'd love for you to read it or listen to it on Audible or wherever else, Barnes & Noble, Amazon. You can get it everywhere. If you're looking for inspiration that will help you unlock your greatness and potential, order or download it today so that you can have your very own copy. And if you get it, please let me know what you think. Number 3, my newsletter. I do a newsletter every Thursday, and I talk about things that are interesting to me or I give more information about the podcast and the podcast guests that I've had and the experiences that I've had with them. You can sign up for the podcast today at my website, which is my name, MikeMalatesta.com. You do that right now, put in your email address, and you'll get the very next issue. The newsletter is short, thoughtful, and designed to inspire, activate, and maximize the greatness in you.